So let us cover variation of parameters today from higher order linear differential equation. So this question is very important. Take the first one. Find the particular integral of d square y by dx square plus y equals to secant x by method of variation of parameters. So first let us write the given differential equation. Given differential equation is d square y by dx square plus y is equal to secant x. Now this equation can be written in symbolic form. How can you write this in symbolic form? D square plus 1 into y is equal to secant x. Okay, so d square by dx is written as capital D square. Now you see, this is equation number 1. Now equation number 1 is a non-homogeneous linear differential equation of the form f of d into y is equal to x. This is equation number 2. Now if you compare 1 and 2, what do you get? Comparing equations 1 and 2, you will get f of d is equal to d square plus 1. And x is nothing but a function of small x, that is secant x. So what is the general solution now? How do you find out the general solution? The general solution is y is equal to complementary function plus particular integral. Now let us find the auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m is equal to 0. That means in the place of d square plus 1, we will write m square plus 1 is equal to 0. So m square is equal to minus 1. So m is equal to plus or minus square root of minus 1. We know that square root of minus 1 is I. So m is equal to plus or minus I. So whenever you get roots in the form of I, you can say that the roots are complex conjugate. Complex conjugate of the form alpha plus or minus I beta. So here alpha is equal to 0 and beta is equal to 1. So what is the complementary function? Complementary function is y is equal to e power ax into c1 cos beta x plus c2 sin beta x. So complementary function is e power 0x into c1 cos x plus c2 sin x. So complementary function is e power 0 is 1. So this can be written as c1 cos x plus c2 sin x. Now we will find the particular integral. So here in variation of parameters, particular integral is found by this formula. Yp is equal to uy1 plus vy2. Okay. Now complementary function, we will take it as equation number 4. And this we will take it as equation number 3. And now this particular integral, we will take it as equation number 5. Now from equation number 4, if you see, y1 is cos x and y2 is sin x. Now here in variation of parameters, we come across a term that is Wronskian. We need to find out Wronskian of y1 and y2. How do you find this? W is equal to determinant of y1, y2, y1 dash, y2 dash. Okay, now what is y1? Cos x. y2 is sin x. y1 dash means derivative of y1. So what is derivative of cos x? Minus sin x. And what is derivative of sin x? Cos x. Now find the determinant. Cross multiply. Cos square x plus sin square x. From trigonometry, we know that cos square x plus sin square x is 1. So you got the Wronskian as 1. Understood. Now, after getting the Wronskian, we need to find out equations for particular integral. What are the equations for particular integral? Equations for particular integral are u dash y1 plus v dash y2 is equal to 0 and u dash y1 dash plus v dash y2 dash is equal to q of x by a2, where a2 is equal to coefficient of d square y by dx square, that is 1. Okay. So hence, we will have two formulas here. What is u dash? U dash is determinant of 0, y2, q of x by a, q of x by a2, y2 dash, whole divided by w. This is the formula we use in variation of parameters. Then how we find v dash? V dash is determinant of y1, 0, y1 dash, and then q of x by a2 by w. This is the way we get u dash and v dash. Now we will substitute the values. You see how I am finding u dash. So u dash is determinant of 0, y2 is sin x, then q of x by a2 is secant x, y2 dash is cos x divided by 1. And how do you get v dash? First we have cos x, then 0, then minus sin x, and then secant x divided by 1. So u dash is, now you cross multiply, you will get 0 minus sin x into secant x. And v dash is cos x into secant x plus 0. This is minus sin x into secant x, we can write 1 by cos x. And over here also secant x, we can write 1 by cos x. Here cos cancel. U dash is minus tan x because sin by cos is tan. And v dash is 1. Now integrating on both sides. Integrating on both sides, u dash will become u is equal to minus, what is integral tan x? Log mod cos x. Minus log mod cos x. And integral of v dash is v and integral of 1 is x. So you will get u is equal to log of cos x and v is equal to x. Now substitute these values in equation number 5. So you will get yp is equal to log of cos x into cos x plus x sin x. So yp is equal to cos x into log of cos x plus x sin x. Now we will find the particular integral. So particular integral is yp is equal to cos x into log of cos x plus x sin x. This is the final answer. Let us cover Cauchy Euler method now. So take the first question. Find the particular integral of x square d square y by dx square plus 2x dy by dx minus 20y is equal to x plus 1 whole square. So we will find particular integral using Cauchy Euler method. So first let us write the given differential equation. The given differential equation is x square d square y by dx square plus 2x dy by dx minus 20y is equal to x plus 1 whole square. This is equation number 1. Now let's say x is equal to e power t. Then log x is equal to t. And d1 means d by dt. Now substituting the corresponding values. In equation number 1. So you will get d1 into d1 minus 1 plus 2d1 minus 20 into y is equal to what is x? X is e power t. So e power t plus 1 whole square. So now multiply this into this into this. d1 square minus d1 plus 2d1 minus 20 into y is equal to, now you open this bracket, a plus b whole square. So e power 2t plus 1 plus 2 e power t. So you will get d1 square plus d1 minus 20 into y is equal to e power 2t plus 1 plus 2 e power t. This is equation number 2. Now what is particular integral? Particular integral is yp is equal to e power 2t plus 1 plus 2 e power t by f of d1. Now separate it. E power 2t by f of d1 plus 1 by f of d1 plus 2 e power t by f of d1. So that is e power 2t by, in the place of f of d1, we will substitute this bracket. Okay. So d1 square plus d1 minus 20 plus e1 means there is no e power. So we will write e power 0t by d1 square plus d1 minus 20 plus 2 e power t by d1 square plus d1 minus 20. So that is equal to e power 2t by, now in the place of d1, because here you have 2t, so we put d1 as 2. So 2 square plus 2 minus 2 into 2 plus, now here you have 0t, so put d1 as 0. So e power 0t by 0 square plus 0 minus 20. This is 20 plus 2 e power t by, now in the place of d1 we will put 1 because coefficient of t is 1. So 1 square plus 1 minus 20. So that is e power 2t by minus 14 plus 1 by minus 20 plus 2 e power t by minus 18. So here 2 ones are 2 nines are, that is minus 1 by 14 e power 2t minus 1 by 20 minus 1 by 9 e power t. Now we will again substitute the values. So that is minus 1 by 14 e power 2t is x square minus 1 by 9x minus 1 by 20. So this is the particular integral. Minus 1 by 14x square minus 1 by 9x minus 1 by 20. Now let us take another question from Cauchy Euler theorem. So the question is x square d square y by dx square minus x dy by dx plus y equals to 2 log x. So this is Cauchy's homogeneous linear equations. So here put x is equal to e power x. So log x will become, let us put x is equal to e power z. So log x is equal to z. So x dy by dx can be written as capital dy. This is equation number 2 and this is equation number 1, where capital D is equal to d by dz. Okay. And x square d square y by dx square is d into d minus 1 into y. This is equation number 3. So these are the standard substitutions we have to take. Okay, now equation number 1 will become d into d minus 1 into y minus dy plus y is equal to 2z. So d square, if you multiply this, d square minus d plus 1 into y is equal to 2z. Now let us consider d square minus, this will become minus 2d. Minus 2d plus 1 into y is equal to 0. Now what is auxiliary equation? It is m square minus 2m plus 1 is 0. So if you factorize this, you will get 1 comma 1. Now roots are real and repeated. Real and repeated. So the complementary function is C1 plus C2z into e power z. So what is particular integral? Particular integral is 1 by d square minus 2d plus 1 into 2z. 2 is a constant, we will take it out. 1 by d square minus 2d plus 1 into z. That is 2 into 1 by, if we take 1 plus d square minus 2d. Now it is in what form? 1 plus x form. If you take it to the numerator, what do you get? That is 2 into 1 plus d square minus 2d whole power minus 1 into z. That is 2 into 1 plus 2d. Because d square minus 2d, if you expand this, you will get 1 plus 2d into z. That is 2 into z plus 2 into 1. 1 into z, because d we are taking as 1. So particular integral is 2z plus 4. So this d of z is 1, no. If you multiply this, dz will become 1. So yp is 2z plus 4. And yc, what is y? General solution. General solution is yc plus yp. So y is equal to, what is complementary function? C1 plus C2z into e power z. And what is particular integral? 2z plus 4. So y is equal to C1 plus C2, z is log x. So we will write log x into e power z is x plus 2 into z is log x plus 4. This is the final answer.